Okay, it's time to jump into Module 1. This is what we're going to be doing at the very beginning of our lab day. We sit down, we look at our lab guide, and some of the advice out there would have you take about 30 minutes and carefully read through the entire lab document. Personally, that's not what works best for me. Personally, that's too much information. If I try to read through everything at a very granular detail and try to remember everything and make copious notes, I'm not going to remember that. There's a lot going on in this lab. What I would much rather do instead is get a high-level overview. I want to see how the lab is laid out. Do I have, for example, a centralized communications manager deployment where maybe my BR1 phones and my HQ phones, they're registering with a centralized cluster? Do I have a separate cluster of communications manager servers at HQ and at my BR1 site? Am I doing clustering over the WAN? Is my BR2 site acting as a communications manager express router? And does it have a Cisco Unity Express module in it? If so, what sort of integration am I going to be configuring on that CUE module? Am I going to be integrating it with Communications Manager Express? Or am I going to be integrating it with Communications Manager, a server at one of my other sites? Those are the big questions I want to answer as I do this initial read-through. So when we do this read-through, I recommend that we take not 30 minutes, but more like 10, maybe 15 minutes at the outside to go through and understand the big things going on in the lab. What kind of gateways do I have? Do I have any trunks? And as I read through the lab, I'm going to show you in this video how we can populate a table that tells us exactly which tasks need to be performed on which pieces of equipment. That way, when I go to that piece of equipment, I can do all or nearly all of the tasks while I'm sitting there. I'm not bouncing back and forth between this server and this router and this switch. I do pretty much everything on the switch, and then I move on to the next device, and then I do nearly everything on that router, and so on and so on. So first we're going to take about 15 minutes or so and read through the lab and make a table of which tasks are done on which devices. And then let's lay a safety net for ourselves. Let's take a couple of minutes and back up our configs. I want to put a backup of my switch config, my router configs. I want to put those in a Microsoft Notepad document. So if something happens horribly on the lab and I need to restore that initial config, I can copy and paste it back in. Or this backup config can also help us when it comes to troubleshooting. Sometimes if we're trying to look through a configuration and we're trying to find what's broken about this link or what's broken about this particular config, it's handy to have all this in a Microsoft Notepad document, and we can just peruse that document instead of trying to do it through the terminal. So we'll lay this little safety net for us and back up our configs of our switch and our routers. And also, I don't trust myself. Under the time pressures of the exam, it is very possible that I'm going to mistype an IP address. And we've got some key IP addresses that we're going to be typing in over and over throughout this lab. We've got the IP address maybe of a publisher at HQ, a publisher at BR1. Instead of trusting myself to type those in correctly every single time and taking the time to type those in every single time, I'm going to take those frequently used IP addresses and put them in another Microsoft Notepad document. And then oftentimes I will just copy and paste the addresses from that Notepad document directly into my interface, whether I'm working on Cisco Unity Connection or Cisco Unified Communications Manager. And something else we're going to be doing in this video is going to our Communication Manager servers and enabling all of the services except dhcp. Keep in mind that in the Collaboration Lab, there may be some traps laid for you. I want to give you some tips on how to avoid those traps. Imagine this, for example. Let's say that you go into your Communications Manager servers and you say, I want to enable all of my services, which would include dhcp. What if dhcp had already been configured on that server and your phones automatically get an IP address? And let's say, furthermore, that auto registration has been configured on your Communications Manager server. Suppose you have phones that are supposed to be using the skinny client control protocol, and they're auto registering using SIP, so now you're going to have to go back and change the firmware. I don't want to prematurely have my phones register, and in order to help prevent that from happening, I want to not enable dhcp yet. I do want to enable everything else because unlike a production environment where I might not need this service or I might not need that other service, here in this lab environment, I want to make sure that all of my services that I might potentially need are at my disposal. And one final thing we're going to be doing in this video is configuring a base set of service parameters and enterprise parameters. And these parameters can vary a little bit depending on how your lab is worded, but in general, I would say over 90% of the base configs that I put in, I'm going to leave. They don't need to be changed during the lab. And what I'm trying to do is eliminate having to make decisions like this during the lab. I don't want us to, during the lab, think, well, should I tweak this parameter? Should I tweak this other parameter? Instead, I've got a set of recommendations of very common service parameter settings and very common enterprise parameter settings that I'm just going to set. And if I run upon a task that makes me go change one of those, not a big deal. I can go quickly make that change, but I don't want to spend a lot of time trying to think through all of these different parameters. I'm going to apply a set of parameters that I've memorized, that I've practiced over and over and over again in my home lab. And as we go through these videos, I want to make sure that you have your lab guide, which contains the solution to the lab. I want to make sure you have that lab guide printed out. That lab guide is available for download in a PDF format. Make sure you have that printed out. It's over 300 pages. You might want to put that in a binder. And in that document, you're going to see that this is the topology that we're going to be working with. You might want to refer back to this diagram frequently to better visualize what we're trying to do. Notice that I've got a server at HQ, and it's running VMware, and I've got 5 servers virtualized on that one physical server. I've got publisher and subscriber communication manager servers. I've got a Cisco Unity connection server. I've got a Cisco Unified Contact Center Express server, and I've got an IM and Presence server, which I've named CUPS, a naming convention left over from when it was called Cisco Unified Presence Server, but that's the IM and Presence server. And notice I've got another physical server attached to the BR1 router. Here I have a publisher communications manager server, and I've got a Cisco Unity connection server. And notice the icon I've used for BR2. This router is going to be acting as a communications manager express router, and it has built into it a Cisco Unity Express module. And on the real lab, the sites might have different labeling than what I've used. I've called them HQ, BR1, and BR2. They might be called something else on the real lab. But notice that at each of my 3 sites, I've got 2 IP phones. I've got a Cisco 9971 phone, and each of those have video cameras built in. And I've got a Cisco 7965 IP phone. Those are the models that, at the time of this recording, Cisco has published are on the actual lab. And I've also got a client PC at the HQ site that's running Cisco Jabber for Windows. And I've got a phone hanging off the PSTN that will be placing calls to and from as well. Let's go ahead and get going with this lab read-through, though. If you have that PDF document printed out, or maybe you're just viewing it on your screen right now, I want us to start reading through the different tasks. And as we come upon a task, I want us to jot down in a table like this on what device or devices do I need to perform that task. If you'll notice, task 1.1 deals with VLANs. And certainly I need to verify or configure VLANs on my switch. And that switch is going to be connecting into my HQ router using a trunk connection. I need to make sure that that trunk connection coming into the HQ router is configured correctly, where we create those sub-interfaces on that incoming interface, a sub-interface per VLAN. We've got VLAN configuration to do there as well. Now, routers BR1 and BR2, they have ether switch modules that are built into them, and they'll need to be configured with appropriate VLANs as well. So I jot down 1.1 VLANs for all of my routers and my switch. Task 1.2 deals with IP address assignment using dhcp. And as we browse through our tasks, we see that at the HQ site, we've got a communications manager server that's going to be handing out IP addresses via dhcp, but we need to make sure that router HQ is configured with the IP helper address command so that it can forward those dhcp requests from the IP phones VLAN to the VLAN on which our communication manager servers reside. We also see that for the BR1 site, the BR1 router, it's going to be configured as a DHCP server. And similarly, for the BR2 site, that router is going to be acting as a DHCP server. But for the HQ site, We said that Communications Manager was going to be acting as a DHCP server, so we put task 1.2 DHCP under that box as well for our Unified Communications Manager. Our next task deals with NTP, Network Time Protocol. And we see that this should be configured on the HQ router, the BR1 router, and the BR2 router. And a note in the task that we're given different time zones for each of these different routers. We also want Communications Manager to be configured with NTP. Communications Manager, after all, is going to be giving out time to the IP phones that have registered with our Communications Manager server. Now we're moving on to task 2.1, where we're talking about registering SIP IP phones, specifically on our Communication Manager servers. This is going to be both at the HQ site and at the BR1 site. So we jot down 2.1 CUCM SIP phones. Our next task, 2.2, is registering skinny phones for both our HQ and our BR1 Communication Manager servers. After we get our phones registered, there's a bit of customization that we're going to be required to do. Again, this is a Communications Manager task. And in addition to registering phones at the HQ and BR1 sites, we also need to register phones at the BR2 site. BR2 is going to be acting as a Communications Manager Express router, and it's going to have one phone configured for SIP, and it's going to have another phone configured for skinny. We need to configure each of those IP phones to register with the BR2 router, and like we did on our Communications Manager server, we're going to have a bit of phone customization to do on our Communications Manager Express router. Now we're moving on to task 3.1, and we see that we've got a gateway that needs to be configured on the router HQ. HQ is going to be acting as an H.323 gateway. And when we set up an H.323 gateway to communicate with a Communications Manager server, there's not really a registration that happens. With MGCP, the MGCP gateway registers with the Communications Manager server. But in the case of an H.323 gateway, they just point to one another. The router points to the Communications Manager server, and the Communications Manager server, it points back to the router, but there is some work to do on the Communications Manager server to point back to that router. We see that in task 3.2, router BR1 is going to be acting as an MGCP gateway, but notice I've put a notation here in our table that says, wait, don't do this one yet. This is an exception to the device-based approach. This is one of the reasons I call it a modified device-based approach. Instead of doing everything on BR1 right now, because this is going to be acting as an MGCP gateway, I want to do the configuration for MGCP first on the Communications Manager server at the BR1 site. Now, I certainly could do everything on BR1. I could manually type in all of the MGCP and all the CCM-manager commands. That would take a while. That's more prone to error. What I prefer to do instead when setting up MGCP is to use a hybrid approach. I like to configure the gateway on Communications Manager, go to my gateway, and then say download via TFTP the XML configuration file that will automatically configure this router as an MGCP gateway. But I don't stop there. I want to make sure that I can make some tweaks, some modifications to meet the task requirements on the router. And at this point, the MGCP gateway on the router is just a minion of the Communications Manager server. I want to break those ties that bind so that I can then make tweaks. I can make specific configurations on the router, and that's what we're going to do. But we've got work to do on both the BR1 router as well as the Communications Manager server at the BR1 site, but we're going to wait to do anything on BR1 until we get to the Communications Manager. Next up on BR2, it's going to be configured as an H.323 gateway to get out to the PSTN. And when HQ is communicating over to BR1, as an example, it's going to do so via a trunk. We're going to have a SIP trunk configuration where we're told that we have to have HQ configured as a Cisco Unified Border Element, a cube. So we've got some work to do there on the HQ router. And the other end of this trunk that's going to be terminating on the HQ router is on our Communications Manager server. And one of the new things in the Collaboration Lab as opposed to the Voice Lab is the addition of video. And we're going to try to set up a video call between HQ and BR1, and we're going to have some issues with that. And we will need to do some troubleshooting. And that troubleshooting can be done on the HQ router, but we're not ready for that yet. So I've put a wait right there. We're going to wait until we get things configured on our Communications Manager server to set up the video call before we start trying to do that troubleshooting. And in task 3.6, we're back over on router BR2, and even though we've configured it as an H.323 gateway to get out to the PSTN, it's going to be acting as a SIP gateway to get back to our HQ site. And our Communications Manager server will need to know to point to that SIP gateway, so we've got some work to do there as well. Now we're going to get into one of the highest point value sections on the lab, and that is call routing. We want to make sure that calls can be sent to, for example, local numbers, maybe emergency numbers, maybe a long distance, international, and task 4.1 describes the requirements for HQ call routing. And because HQ is an H.323 gateway, we might have to have some dial peers, one or more dial peers set up on HQ to help us with that call routing. Of course, the main call routing logic is going to be done on our Communications Manager server. And task 4.2 is dealing with BR1 call routing. However, we don't really have much of anything to do on the BR1 router for that call routing because it's an MGCP gateway. It's going to be taking its call routing instructions not from local dial peers on the router, but from Communications Manager. So we're going to be configuring BR1 call routing on the Communications Manager server at the BR1 site. Task 4.3 deals with call routing at BR2, and once we've got basic call routing set up, we see that we have in task 4.4 some requirements to do number globalization and localization. And what this is about is formatting incoming calls to appear a certain way on our phone's display. For example, a local call maybe should only show 7 digits on the display. But if we go into call history, I want to see all of the numbers. I want to see the fully globalized number so I can call that number back no matter where I am in the world. Our next task deals with a new feature in Communications Manager version 9, and that is URI dialing, where we're dialing not using a phone number, but instead we're using a URI, which looks a lot like an email address. Now we're ready for task 5.1. We're setting up a video conference bridge on router HQ. This is something else that's new to Communications Manager version 9, the ability to do video conferences on our router. And here we have to be using at least a Cisco ISR2 router, such as a 2900 series or a 3900 series router. And we've got to have plenty of PVDM version 3 resources inside of our router. And what I have in my HQ router is I've got a PVDM 3 128 and a PVDM 3 64. Takes a lot of DSP resources to do a video conference, although I think you can get by with just a single PVDM3 128. Once we set that up on the HQ router, it then has to be defined on our Communications Manager server, so we'll put task 5.1 video conference bridge for our Communications Manager server as well. And speaking of conferencing, task 5.2 has us set up ad hoc conferencing on router BR2. In tasks 6.1 and 6.2, we're dealing with quality of service, QoS, and specifically task 6.1, that's going to be done on switch SW1. In fact, these are all of the tasks that need to be done on switch SW1. So as we get going, and we'll see this in our next video, we can do task 1.1 on switch SW1, task 6.1 on SW1, and we're done with that switch for the balance of our lab. Nothing else to configure there. That's one of the beauties of this modified device-based approach. We also have a quality of service task for the link going between router HQ and router BR2. We've got work to do on each of those routers. Now we're ready to move into section 7 of our lab, which deals with voice messaging, Cisco Unity Connection, and Cisco Unity Express. There's some preliminary work we need to do on our Communication Manager servers to get ready to integrate them with Cisco Unity Connection. And as we peruse the lab, we're going to see that we're going to have a skinny integration with the HQ Cisco Unity Connection server. And we'll need to set up that CUC server at HQ. But we also have a CUC configuration at our BR1 site. It's going to be a SIP integration. Again, there's work to do on the Communication Manager server at BR1, and there's work to do on the CUC server at BR1. And once we get that set up, there's a bit of customization that we're going to be asked to do on one of our CUC servers. We want voice messaging services available at the BR2 site as well. And that's going to involve the configuration of our CUE, our Cisco Unity Express module. Before we go to that Cisco Unity Express module, though, we've got some preliminary work to do back on router BR2. We need to get that Cisco Unity Express module initialized where we can communicate with it. Then we'll go over to the Cisco Unity Express module in task 7.4, and we will initialize it. We'll do some basic configuration of it, and we're going to integrate it with our Cisco Unified Communications Manager Express router, specifically router BR2. We've got to do some work on router BR2 for that to happen, and we've got some work to do on our Cisco Unity Express module. And once we get that set up, just as we had with our CUC server, we've got a bit of a customization that we want to do. And that might require some work on both the BR2 router as well as the Cisco Unity Express module. We're done with our voice messaging now. We're ready to move on to Cisco UCCX, Unified Contact Center Express. The first thing we're being asked to do is to integrate UCCX with our Communications Manager server at the HQ site. So that means we've got some work to do both on the UCCX server and on our Cisco Unified Communications Manager back at HQ. Once we've got that integration complete, then we want to do a bit of scripting. It's like we're putting on our programmer hats right now, and we're modifying a script to accomplish what the task is asking for. And many times when you're working with UCCX scripting, you're going to need to create a custom prompt. You're going to need to record something specific, and a really easy way to do that using the equipment that we have on the lab is to use our Cisco Unity Connection server to record some prompts that we can then use and reference in our script. That's the reason we put task 8.2 UCCX scripting under our CUC server as well. And the final major section of our lab has us dealing with the IM and Present server. The first thing we need to do is to integrate the IM and Present server with our Communications Manager server at the HQ site. So we've got work to do both on the IM and Present server as well as on the HQ Communications Manager server. And once we've got that integration complete, we want to configure Cisco Jabber for Windows. We're going to be setting up a video call between a Microsoft Windows client running Jabber and one of our HQ Cisco 9971 phones. And what we've been able to do in about 10 to 15 minutes, obviously it took longer than that for us because I was giving a lot of narration as we went through, but on the lab that process should have taken no more than about 10 to 15 minutes to quickly read through all of our tasks and to list under which device or devices do we need to perform each of those tasks. We've now got a solid game plan that we can use to confidently attack our day. Before we get going though with that first task 1.1 on our switch, we want to lay a safety net for ourselves. So we want to make a backup configuration of our switch config and all of our router configs, and we can do that using a Microsoft Notepad document. Let's go over to switch SW1 and we'll do a show run, and I'll just spacebar through all the configuration. And then I will highlight everything. Scroll up to the top here. Let's highlight everything, and I'll do a copy, paste into my Notepad document. And in my Notepad document, I'll make a notation up at the top that this is switch SW1. And let's go down a bit below, and let's enter the configuration for router HQ. Now, hopefully we're not going to need this, but it might come in handy when we're troubleshooting. It might come in handy if we do something that's not easily reversible. That's happened to me a time or two, and I want to paste this configuration back in. It's nice to have this safety net, and it should only take us a couple of minutes to do this. So again, I'm going to do a copy. Let's go up to the top of this guy. And let's paste that in. Let's do this again for BR1. And again, we'll do a show run. And let's copy the output once more. Copy, paste. And the last device on which we'll do this is router BR2. Do a show run, do a bunch of spaces, and let's highlight, copy, and paste. And the way you do the copy and paste might vary depending on your particular terminal emulator. All right, and we could then go ahead if we wanted to and then save this notepad file. Now that we've done that, notice I've got another notepad document open. There's something else I'd like to do. I want to take a look at my lab guide and copy down some of the commonly used IP addresses. If we look at our documentation, we can see the IP addresses for commonly used interfaces or VLANs. What I'd like to do is to, in this notepad file, write down the IP addresses of these commonly used IP addresses. That's going to allow me to copy and paste them from this notepad file into my interface, whether I'm working on Cisco Unity Connection or Cisco Unified Communications Manager or the IM and Present server or UCCX. Let's do this. Let's say for the HQ CUCM server, specifically the publisher server, it has an IP address of 192.168.1.71. I'll do a quick double check, make sure I get that right. Let's do the HQ CUCM subscriber server. It's 192.168.1.72. I'll also do the BR1 CUCM publisher server. Not doing everything, just the ones that I'm going to use probably most often. And it has an IP address of 10.10.150.71. Let's also capture the IP addresses of some common interfaces that we might be using, such as voice VLAN interface IP addresses. I'm going to say for HQ Gigabit Ethernet 0/0.200, which is my voice VLAN, it has an IP address of 10.10.120.1. I'll put in the loopback IP address for HQ as well, HQ loopback 0. That has an IP address of 10.10.32.1. Let's do a couple for BR1. BR1 has a voice VLAN of 400, and that has an IP address of 10.10.140.1. We'll get its loopback interface as well. BR1 loopback 0 has an IP address of 10.10.32.2. And finally for BR2, its voice VLAN is VLAN 600, with an IP address of 10.10.160.1 and a loopback IP address of 10.10.32.3. And then I can save this document as well. Something else we want to do is to start our services on our servers, with the exception of dhcp. As I mentioned a few moments ago, we don't want to fall for a trap that might have been laid for us where a server may already be configured with DHCP, the IP phones boot up, they obtain an IP address via DHCP, they auto-register using the incorrect signaling protocol based on our task requirements. Let's prevent that from happening until we're ready for DHCP. Here's what I'm going to do. I'm going to go into the HQ cluster, and I'll go into Cisco Unified Serviceability. And let's go under Tools, Service Activation. I'll select the Publisher server first. And notice by default that pretty much everything is deactivated. I'm going to say check all services, but I'm going to turn off, I'm going to uncheck the Cisco DHCP monitor service. I don't want that running yet. And let's say OK. That's going to take a while. Notice I've got a different tab open. I typically use different tabs. That way, if one server's busy doing something like this, I can go to another server. I'm over at my BR1 cluster now, and I'm going to go under Cisco Unified Serviceability. Let's say go. And under Tools, Service Activation, I'll do the same thing. I'll say check all services except, let's turn off DHCP. We'll uncheck the Cisco DHCP monitor service. And I'll say save. And while that's working, let's go back over to the HQ site. Hopefully it will be updating in a moment, and then we can do the subscriber server. And it looks like our HQ cluster has finished. Notice that everything is activated except DHCP, and that's perfect. Let's go to our subscriber server in this cluster at HQ. See what's activated or deactivated there. Looks like everything is activated other than DHCP. Beautiful, that's what we want. So we're in good shape on both of our HQ servers. What we want to do now is remove DNS reliance so that these communication manager servers are going to be known by their IP addresses as opposed to their DNS names. To do that, we need to go to a couple of different screens. First, let's go back to our administration screen, and again, we're on the HQ server right now. And we're now going to go under System and Server. Let's do a find. And notice that the publisher right now is known by its name rather than its IP address. Let's change that. Let's make it known by its IP address. And I'm not trusting myself to type it in correctly. I've already got it typed into my notepad document. So I'm going to select, copy, and paste, and we'll save that. But that alone does not completely remove DNS reliance. I also need to go into my enterprise parameters. We'll go under System, Enterprise Parameters, and if I scroll down just a bit, you're going to see a series of URLs. Here's the authentication URL, the directories URL, and so on and so on. Notice that these URLs have the name of the server as opposed to the IP address of the server. To truly remove DNS reliance, which is generally what we'll want to do, I want to replace the name in each of these instances with the IP address of my publisher. To do that, I've already got it copied. I'll just say paste. So I highlight the name of the server and say paste. And paste. Got a few more to do. Paste. Actually, I missed a 1 right there. Got to be careful to highlight everything. Paste. 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 And paste. Just doing a quick sanity check, doing a check to make sure that I've got everything correct. It all looks good to me, and while we're here in the enterprise parameters, there are a few other enterprise parameters that I commonly set when I'm initially setting up a cluster. I will generally set the auto registration protocol to skinny, and it already is. I will generally set the BLF for call lists to enabled. We might not know yet if we have that particular task or not, but I generally set it to enabled. And as we were reading through our tasks, we might have noticed that G.711 should be used for calls within a site. I don't want G722 to be negotiated. So when it says advertise G.722 codec, I'm going to disable that. Let's disable the advertisement of G.722. And I'm going to save that change. And then I will do a reset. Oftentimes we have to do a reset in order for things to take effect. We also want to change some service parameters. I'm going to go under System, Service Parameters, and I'll select the publisher server. However, for lots of service parameters, even if we change the parameter on the server, it's said to be a cluster-wide parameter. It will change it for the entire cluster, not just the publisher. And the service is going to be Cisco Call Manager. And let's scroll through here, and I'll point out the common service parameters that I normally change. As we scroll through, I'm noticing this timer, the T302 timer. This is the interdigit timeout timer. How long does an IP phone wait before placing a call if more digits might be dialed? How long between digits will it allow before it says, I think they're done dialing, and try to place the call? The default is 15,000 milliseconds. Careful with the unit of measure. I normally set this to 3 seconds. In other words, 3,000 milliseconds. You don't want to set that too low. Let's do a 3,000 millisecond setting. And there's another one of these T302 timers. Let's scroll down and get it. Here it is, H225 T302. Again, I'll change this to 3,000. Not 3, but 3,000. And also, there are a few parameters that say stop routing if this happens, stop routing if this happens. I want to set all of those stop routing parameters to false. I don't want to stop routing. Here we've got a stop routing on out of bandwidth flag already set to false. I want to set all of these stop routings to false. Sometimes if you have a route list and you've got a secondary entry in your route list, sometimes that secondary entry will not be used if you just leave all these at their default values. And there's also a stop hunting on out of bandwidth flag gets set to false. Any of these stop routing or stop hunting settings, I want them to be set to false. And we mentioned earlier about the G.722 codec. If we don't want that to be used, we can say that we want to disable that. Here we see G722 codec enabled. I'm going to say that is going to be disabled because we want to use G.711 instead. And as we were reading through the lab, one of the things that we should have been looking for is what codec is going to be used within a site. It was G711. And what codec is going to be used between sites. And in our case, it was ILBC. So I want to set the default inter-region max audio bitrate to 16 kilobits per second because we're using ILBC. If instead we were using G.729, I would set it to 8 kilobits per second. So I'm going to change this to 16 to support ILBC. If we have to set up AAR, Automated Alternate Routing, it is disabled by default, so I'll generally set that to a true to enable it. Also, if we're using Cisco Unified Mobility, we probably want to change some of these parameters, so I generally set them up the way I want them to begin with. I'll say that I want to enable Enterprise Feature Access. It's set to false by default. That allows you to use a keypad to invoke enterprise-like features if you're using Cisco Unified Mobility. I'll say that I do want to enable Mobile Voice Access, MVA, and if I'm calling in from a remote site and I want to be recognized as me, as my number, I don't want my caller ID to have to completely match up with the phone number that's defined as my remote destination number, because that number probably has something like a 9 to get an outside line. My caller ID isn't going to have a 9 in front of it. So I'll say that I want a partial match instead of a complete match, and generally I'll say that I only want 7 digits. The 7 rightmost digits have to match between my caller ID coming in and my remote destination number. That's going to identify me as being me to the Cisco Unified Mobility service. And those are the settings that I typically give when I'm setting up a brand new cluster. And if that seems like a lot to remember every time, please keep in mind that when you do this repeatedly, you're going to do practice lab after practice lab over and over and over and over. You're going to get good at this where you can very quickly remember what settings you want to set. So please, at any point during this course, if you feel yourself being overwhelmed thinking that's way too much to remember, just set your mind at ease that you're going to learn it with repetition. Now, we've set up these enterprise parameters and service parameters on our HQ cluster. Let's go do it on our BR1 cluster. We'll go back to the administrative screen and get out of the serviceability screen. And the first thing we'll do is remove DNS reliance, as we talked about before. We'll go under System Server, and I won't give as much narration this time since we already talked about these things. I'm going to go into the server's name, and I'm going to copy, paste to give it its IP address instead of its name. Then I'll go into my enterprise parameters. And by the way, we did not have to update the name to an IP address for the HQ subscriber. It was already set up with the IP address, you might recall, so we didn't have to do anything there. Now under enterprise parameters, let's go down to where we find our URLs, and let's highlight the name and paste in the IP address in its place. And I'm trying to be careful to make sure that I'm selecting the entire name. Just a few more URLs to go. All right, just double checking. That all looks good. Remember, we did have a few other enterprise parameters we wanted to set up. We'll go ahead and take a look at those while we're here. The auto registration protocol is set to skinny. Great. I want to enable the busy lamp field for call lists. We'll say that that is enabled. I do not want to advertise the G.722 codec, we'll say. We'll disable that. And we'll save these enterprise parameter settings. And we'll do a reset. Oh, and by the way, it popped up off screen. When you do a reset, it pops up a separate window where you say reset and close. It popped up on a separate screen when I did that before. I wanted to make you aware that there is a window that pops up that allows us to confirm that we really do want to reset these things. Now, let's go under System Service Parameters. And we've just got the one server. And we're going to go into the Cisco Call Manager service. And the first thing we do is set those timers. We want a 3-second, or sometimes I've seen Cisco use a 2-second. I typically use 3 seconds. We'll say 3,000 milliseconds for my interdigit timeout for both of my T302 timers. And here's my second one. We'll set that to 3,000. Anything that says stop routing or stop hunting, I don't want that to happen. So I'm going to say false to anything like that. Stop hunting is false. Stop routing, let's set that to false. Stop routing, let's set that to false. Let's not enable the G.722 codec based on our task requirements. Your task requirements might be different in the real lab, so please keep that in mind. Where did that go? Here it is. G722 codec enabled. I'm going to say, nope, it is disabled. My default inter-region bandwidth is going to support IOBC, so that's going to be 16 kilobits per second. I'll make sure that if needed, we can use AAR, Automated Alternate Routing, and we want to set up some things for Cisco Unified Mobility just in case. I'll say that yes, we want to enable Enterprise Feature Access. I want to enable MVA. I don't want to make a complete match. In fact, I only want to match 7 digits, and we're done with that. Let's save that. And we've now done the preliminary work. We're now ready to jump in to our very first task. And that's what we're going to do in our next video. But before jumping into that next video, let's take just a moment and highlight some of the key lessons that we want to extract from this module. We said that we wanted to begin our lab day by reading through the lab, taking about 10 or 15 minutes to do that, populating that table listing each of our devices, and we say under which device is each task going to be performed, and it might be under more than one device. We then did a backup of our configuration on our switch, on our routers, to a Microsoft Notepad file. We also opened up another Microsoft Notepad file and documented frequently used IP addresses, loopback IP addresses, voice VLAN IP addresses of our publisher servers. Then we went into our Communication Manager servers and we enabled all of our services except dhcp, trying to prevent a premature registration of our IP phones. Then we went in and set up a collection of service parameters and enterprise parameters. Now that we've done this, which in the real lab should take well under 30 minutes, I know this video was well over 30 minutes, but that's because I did so much explanation as we were going through. I'm thinking around the 20 to 25 minute mark maximum. We should have all of this done and we're ready to start our tasks. And we'll start our first task in our next video.